Given the following hypotheses, find the probability of detecting a true population proportion of 0.380. Suppose all conditions are met. So we have a null hypothesis of 0.360, proportion, population proportion hypothesized, so we'll call that P sub 0. Alpha is 0.05, our sample size is 250, and so this is our hypothesized distribution. This is a two-tail test, so we would have 0.025 in the left tail and 0.025 in the upper tail. Alpha over 2 then would be 0.025, in other words. And these z-scores would be 1.96 and negative 1.96. The question is to find the probability of detecting a true population proportion of 0.380. What that means is to find the power. And the first step in doing that would be to convert these z values to actual proportion values. And in order to do that, we would use this calculation. Z is equal to p hat minus p sub 0 divided by the square root of p0, 1 minus p0 over n. What we know here is z, p0, and n. What we don't know is the sample proportion that would put us at these two spots here. And we could calculate that by rearranging this formula a little bit so that it would look like z times the square root of p0, 1 minus p0 over n plus p0. So we would have 1.96 times the square root of 0.36 times 0.64 divided by 250 plus 0.36. And when we do that calculation, we find 0.420. If we do this same calculation and let z be minus 1.96, we would then wind up with a left. So I'm going to put a little L there and a little right here, R here for right. Our left value would be 0.300. So we are supposed to find the probability of detecting a true population proportion of 0.380. So unknown to the researcher, this population proportion is 0.38, which is between these two values here of p hat left 0.300 and p hat right 0.420. So it's somewhere in here. So this is where our actual proportion will be. So we'll call that P1, 0.380. And our distribution then will be centered on that value. Now, projecting these values to this curve, we find that we have much more area in the tail here than we had here, and less down here than we had, supposed to be less. I drew it a bit wide on this left-hand side. But the question really is, what is the sum of this area and this area if the population proportion is actually 0.380? So the next step then will be to calculate the z-values associated with these p-values, these p-hat values of 0.420 and 0.300 when p, the population proportion, is 0.380. So that'll be, again, using this same formula here. This time we'll calculate the z-values, so we'll leave it in this form. So we'll have P hat will be 0.420 for the right-hand side. So Z for the right-hand side, 0.420 minus 0.380, or 0.38, divided by the square root of, now our proportion for this distribution is 0.38. So we'll have 0.38 here and 0.62 here and 250 here. And that z-value comes out to 1.30. For the left-hand side, we'd have 0.300 minus 0.380 divided by, and again now, the 0.38, because we're working with this other distribution, times 0.62 over 250. And for this value, we will get minus 2.61. So the z-value here is minus 2.61, and the z-value here is 1.30. And by now, you are perfectly capable of looking up z-values either in a table or using a utility such as a TI-84 calculator or StatCrunch. And what you would find if you did that would be these areas here, and you would find 0.097 here and 0.005 here. And so the power will be the sum of those two values. And so the power this time turns out to be 0.102. That means then that beta, the probability of committing a type 2 error, would be 0.898. 1 minus 0.102. And so we can see that that's a very large probability, and if this particular population proportion is actually 0.380, that is not a very large probability. In other words, it's not very likely that we would detect that true population proportion. So something would have to be done in order to increase the power. In the next video, we'll look at what effect increasing the sample size has on that value.